Hello, everybody. I'm just going to assume that we're live. Welcome to this Parabolic Flights Altered Gravity Science Hangout. I'm Julien Harrod from ESA, and I'm joined with the project managers for Parabolic Flights from the respective agencies. This is Sebastien and Rouquette from CNES, from France.
Hello, everybody.
This is, to his right, is Vladimir Pletser from ESA.
Hello, everybody.
Based in the Netherlands at ESTEC. And to his right is Ulrike Friedrich from DLR.
Hello, everybody.
So to start, I would like to ask Vladimir, what exactly is a parabolic flight and why do we do this?
Okay, parabolic flight is a flight that we do with an aircraft, with a laboratory aircraft. I have this little model here to explain. On board this aircraft, we have researchers, and we are flying this aircraft, the pilot flies this aircraft in a special trajectory to create zero gravity. Zero gravity means weightlessness, so to be in a free fall state. So from an horizontal flight at about 6,000 meter of altitude, pilot will accelerate, so put full thrust to the engine, same time pull on the command, bring the plane in a climbing position, same time accelerating, so the speed would increase, would rapidly decrease because it's going against gravity. And then when the angle, the climbing angle, reached 47 to 50 degrees, the pilot suddenly shut down the engine, so cut the engine, so no more thrust. So the sum of all forces acting on the plane other than gravity is zero. The plane is suddenly in a free fall state and will start to free fall, even if it goes first upward, because due to its initial velocity, it would use all this velocity and exchange for potential energy and would come to a top of a trajectory, which is at about 9,000 meters, and would continue to fall down, but this time downward. When the diving angle reached about 42 degrees, it's time for the pilot to put full thrust back again and come back to an horizontal flight again at 6,000 meters. We repeat this 31 times indeed per flight. We have 3 flights in a row, in 3 days in a row in the campaign, and each flight gives us 10 minutes of zero gravity in slice of 20 seconds. 3 flights give us then 30 minutes, and if we do 3 campaigns in a year, that would give us the equivalent of 1 orbit on board the ISS on board this plane. So of course, a slice of 20 seconds feels like it's a bit short. If you are well prepared, if you are well trained, it's long enough to do meaningful science, to do experiment, to do research, to conduct research program, and to prepare also future mission on ISS. The advantage of this flight is that you can invite scientists to come on board and perform by themselves the experiment on board the aircraft, and which is the only means in the world where you can have scientists doing their own experiment in a zero gravity environment. So this is truly a research laboratory where we can modify the gravity level. We can go to zero gravity, 0G. We can recreate also the gravity that we will have on Moon or on Mars by slightly modifying the flown trajectory, and we can then recreate about 1/3 of Earth's gravity to correspond to the Mars gravity, which is about 0.38 G, or the Moon gravity, which is about 1/6 of Earth's gravity, so 0.16 G on board this aircraft. I hope this answers your question.
Sorry, I just had to sneak out there for a second. Did you answer why we do this?
I think I did, yes.
Okay, sorry. As I said, I just had to sneak out for a technical problem. Okay, one of the reasons we're here today is because Novespace, the company that's running these parabolic flights, has inaugurated a new aircraft, the Airbus A310. It had its first flight for scientific research yesterday, so today was the second flight. Can you tell me how it went? How was the new aircraft?
Mm-hmm. The new aircraft was wonderful. It had very smooth, very good parabolas. Good is the meaning that the gravity level, the microgravity level, is very, very good, so that it is close to real weightlessness. And that is important for some experiments, of course. And so everything went fine. The experiments, 12 experiments we have on board, they were performed successfully.
But it was very exciting to have these first flights yesterday and to enjoy with microgravity with this new aircraft. In fact, yes, it is a very good level of microgravity. So when you want to perform experiments in this aircraft, it's a very good level that allow to make some very good measurements in each domain you can work.
And I think it is a good example that many people, engineers, scientists, technicians, they did really a great job.
If we go back in history also, I would like to mention that it's also a very special anniversary for us at ESA as well, because 30 years ago, nearly 30 years ago exactly, we had our first campaign. That was December 1984. I was not even yet at the agency at the time, but my colleague Dave Freemau, the first Belgian astronaut, was taking care of this flight, parabolic flight. And at that time, the European Space Agency went to Houston to fly with the KC-135 from NASA. And we did there. I joined after 1 year, so I was there late 85. At that time, these campaigns were used to prepare Space Lab mission. And the scientists who had an experiment on Space Lab mission were invited on board to train also with the astronaut to perform their own little experiment, little look and see experiment. Then it was realized that they could produce actually good science during this flight. And then we decided to embark on this scientific program to be conducted during parabolic flight. And I'm very pleased, very happy also to see that thanks to an excellent cooperation with my German colleague and my French colleague, that together we managed to pull up this plane, and with Novespace as well, to have this new plane starting now for microgravity research, we hope for the next 20 years.
That leads me into the first question, because viewers can ask questions via Twitter. Can parabolic flights for weightlessness be done on any aircraft in theory?
Yeah, in theory, yes, because this aircraft hasn't been modified for this. The only modification was in the cabin, so in the central part of the aircraft, to provide the experimenters electricity, lights, and also protection around the cabin. So no modification of the aircraft itself, the wings or the engines. Everything is has been produced with the aircraft. So the aircraft has not been modified in its structural components.
Okay, so then I have my own question. So what was the choice for this aircraft? Are you looking for big internal volume, or? Well,
already the A300 was the largest aircraft at that time for the last 17 years, which was used for this type of flight for research. And it's the only aircraft in the world that could accommodate 12, 13, 14 experiments at a time, quite huge, quite large experiment, and 40 people, 40 researchers during one single campaign, and each time providing a 3 flight. Also, it's not only the flight itself, but also the service that the agency and specifically also Novespace, the integrator, provides in support to the experimenter. So that means that all the advice for building the hardware, assemble it, integrate it, accommodate it on board the aircraft, and then provide also a team of pilots and all the crew, cockpit and cabin crew, to help to support the experimenter. So we are here to help the scientists to provide us with the best scientific result possible. And this type of know-how, this type of expertise is really unique in the world. Our American colleague or Russian colleague do not have this capability as good as we have it. And for this, we can be quite proud of the knowledge, the expertise that we develop here in Europe, thanks to all this effort over the years to produce such an environment which is unique for gravity, altered gravity or partial gravity or zero gravity environment for reduced gravity research.
Maybe I'd like to give a second part of the question, if you can fly parabolas with every aircraft. Yes, you can, technically speaking, but the manufacturer of such aircrafts, which are flying all over the world, he will write in his user book, oh, it's forbidden to fly parabolas.
Right.
And so it is a huge work, administrative work, or work for certification, together with authorities in different countries to get the flight approval for such maneuver. That is, of course, important. So, yes, technically spoken, you can fly, but from what the institutions allow, that's very, very...
You can do it. You can do it once without any problem. Maybe a second time, but not repeat, because actually the engine would stop, and then it would be a very long dive. Because of course, the liquids in zero-G would start to float, in all directions. So the most important thing, of course, is fuel. I mean, the carbon, the fuel that you use for the engine, but also the lubricant, the oil that you use for lubricant. And the oil has to be in certain place in the engine. If it starts to float away in zero-G phase, you're not sure that at the end, when you need the engine full thrust, that the oil will be where it's supposed to be. If we're on board, we will make sure that the process that we apply is safe and safe enough to invite investigators, scientists from all over the world, Europe, but also from all over the world, to join us and do the experiment on board.
Yeah, and we've never been frightened by the flights.
But I would like to join you one day. And with that, you answer the question of Florian Sachse, who actually asked if it was dangerous to perform a nose dive with a plane like this. So maybe we can move on to the science, to the actual experiments. For this campaign, this joint campaign with ESA, CNES, and DLR, there are 12 experiments. Would any of you like to talk about them briefly as an introduction?
Okay, I can make a summarizing of these experiments. We have 5 experiments in the field of medicine, human physiology, and sports science, and we have 2 biological experiments and 4 in the field of physics. And we have also mere technological experiments. That means they test some technology, if it works in weightlessness as if it is in weightlessness outside in the orbit.
And if you want to see a little bit of the geographical distribution, ESA is sponsoring 6 experiments, DLR is sponsoring 4, CNES sponsoring 2, but in total we have 8 German experiments, because of course DLR has 4 German experiments, ESA has 4 German experiments. We have also 1 French experiment in addition to the 2 French experiments on the CNES side, so it makes 3 French experiments and 1 Belgian experiment. So you see it's spread all over 3 countries, although we have experiments usually coming from all over Europe, also from Italy, from Belgium, from Holland, sometimes from Norway or Sweden or UK as well. So it's all over Europe, basically.
Okay, excellent. Moulana Mouama Afifi was interested to know if there are any particular areas that each agency focuses on in terms of experiments. Any kind of scientific area that you have a priority on? Maybe you could talk each about that.
Oh, well, probably I would say that on my mind, we don't have many differences in our approach, and we select experiments in a very wide field of science. So, as you mentioned already, we have biological experiments, physiological experiments, and material sciences, and and technical also. So everything that could be interested in the opportunity to fly in zero-G could be interesting. So we just have to select and help the teams to prepare their experiments in order to be bored in the aircraft. So in CNES, the main fields we focus on are human physiology and particularly neurobiology, and also material science and fluid sciences. So these are the main fields which share almost 80% of the places on board the aircraft.
Maybe I can add that I think all three agencies have a so-called user-driven program.
Mm-hmm.
So if there are scientists in a country or in whole Europe who are making research on topics where gravity and also zero gravity plays a role, then they can submit proposals, and whenever we can, we fly such proposals then on a parabolic flight. Of course, the scientist may also use other scientific platforms like rockets or satellites or a space station, of course, or the drop tower. It depends on the duration of weightlessness they need for to answer their scientific questions, and also of the level of the quality of microgravity, which is available in these different flight opportunities.
Also for ESA, of course, we are absolutely complementing what CNES and DLR is doing, but I want to say as well that we have what we call a CORA approach. CORA stands for Continuously Open Research Announcement. That means that anybody can submit at any time a proposal for an experiment. So among you, viewer and listener, if you have an idea that you want to test in public flight or in zero-G, well, you're welcome to go on the ESA website, find out and download the proper document. If you go on the human space flights research section, and then you will see announcement of opportunity, you will find the CORA document, so Continuously Open Research Announcement. These proposals are received, can be received anytime. They will be sent for review by external peers, external scientists, or technician or engineer, who will rate and rank your experiment. We have also another approach, which is to try to gather scientists who have the same goal. Instead of receiving proposals from teams who worked on the same field but independently from each other, we invite them first to talk to each other, to put their ideas together, to exchange views, to see what would be the best approach to cover one particular problem and exhaust a complete range of parameters. And this we call a topical team. And this team then, after discussing internally, submit to us, to the agency, whether CNES or DLR, or to us at ESA, a consolidated, a joint research program. And that could cover not only parabolic flight, but the entire range of platform, microgravity platform, like my DLR colleague Ulrike was mentioning. We have drop towers for a few seconds. We have a parabolic flight for about 20 seconds apiece. Then we have a sounding rocket that will give you several minutes, and then satellites, automatic satellite that will give you several days, and the ISS, which will give you permanent access to zero gravity.
Okay, thank you. I have another question to each of you. What are your favorite areas of zero-G research and why? Briefly.
So each question is very interesting. And also the young scientists, they are working on these experiments, or they have planned and manufactured these experiments. They are so enthusiastic. Of course, one looks to those first where you can see something directly. But all of them are as important as the others.
Great answer.
What about you, Vladimir?
Okay, I have several in mind. Well, my background is I'm an engineer, but also I'm a physicist. So on board this campaign, we have two experiments which are, for me, particularly interesting as an astrophysicist. Is that they study dust aggregation, collision of dust grain, to recreate the condition or similar condition what you have in protoplanetesimal disk around protostars, or like to simulate, let's say, the birth of our solar system, to try to understand the process from which the planet could eventually form from the dust and the gas into this disk around stars. The other one studies the gas flow through porous media to try to understand processes that are acting on the surface of planet Mars, for example, with the dust devil, also acting on the dust particle in the rings around Saturn or around the giant planets. That's one category of experiment that I'm really interested in. What I like particularly are those experiments also where you can see a real application, and in terms of human physiology or human research, those experiments that eventually would bring also quite a significant enhancement in life, in everyday lives of human beings. I'm thinking more particularly to a series of experiments that was conducted by one of our researchers, the team of Professor Jean-Louis Tonard and Professor Philippe Lefebvre, on dexterous manipulation. They conduct this research for the last 15 years. They got a lot of results. They published a lot of papers. They got several PhD theses out of it. And we developed also, we built an instrument to fly on ISS, to perform this experiment on the ISS. The long-term application of this is not only to understand what is the intrinsic behavior and how the brain, how to say, integrate this new knowledge of the position of the human limb, and how to control it, but also eventually to come up to develop new algorithms. And when you see this result, not only that it brings basic knowledge on how the brain is coping, how the brain is functioning, and also how it connects to the arm to make this very simple movement, but that require so many different integrated motion of the shoulder, the elbow, the upper arm, the hands, the fingers, and so on. But then that it has this potential application in very near future that you could enhance the life of those people who suffer this accident or suffer an handicap from birth. This is very, for me, very strong and very important to show that basic research like we conduct sometimes have also application, not always in immediate future, but most of the time also in medium-term future, but also those research that you do not see in advance the application would eventually have some application in the future, but you don't know simply that in advance. And that's why it's important also to support basic research like we do in microgravity.
That's right.
Your turn.
Yeah, it's my turn, and it's not very easy because I speak at last. So, well, as an astrophysicist, I could say that I'm obviously very deeply interested in astronomy and astrophysics experiments. So, what to talk about when experiments deals with dusts and light signatures of this kind of dust clouds, it's very interesting, for example. But when I came in parabolic flight for the first time, I was really interested in by human physiology because of the knowledge it brings about the adaptation of our brain and also our body to this new environment, which is microgravity. And I think that it's very interesting, and particularly if, as you said previously, particularly if you can have some direct applications. So it is, but I would say that, in fact, finally, everything that is boarded in this aircraft is completely interesting and amazing.
Yes, fascinating. And as you say very correctly, we are at the edge of science here. We are top-notch. We have top-notch experiments, scientific experiments that we fly. We only fly excellent, outstanding, excellent, very good experiments. So this is really the top-class, world top-class science that we have on board this aircraft.
Okay, fascinating stuff. I would like to ask Dr. Franck Ditengou to come and take my place. He's flying one of the experiments of the 12 we haven't mentioned yet. It's about plants, growing plants in weightlessness, but he's the best person to explain. I will let him sit down and take over. If you could explain your experiment and why you do it.
Yeah, Notre experiment is dealing with understanding how plants actually perceive and respond to gravity, because plants, just like we humans, can sense gravity, and they have to they had to cope with gravity all over the evolution. And they developed mechanisms that allow them to convert this external signal into a developmental response. So if, probably all of you have seen it. If you just take a plant, you put it to lie on the table, you will see that it will reorient itself. So the gene signatures, the gene expression signatures are completely new. We were expecting to see something that will be specific to gravity, but what we see is a new type of response. And so once we have this type of results, what we try to do is to dissect one by one. Mm-hmm. And in the particular experiment that we are running right now, we want to look precisely in the root, precisely in different cells inside the root, how they respond to gravity. Will we change the cell structure? Will they elongate? Will they swell, for example? So this is what we're trying to understand in this particular experiment. So we have a camera that follows the root in 2D to record the growth during the different phases of the parabolic flight. And afterwards, we apply some confocal microscope analysis in order to record some virtual sections of these roots, and treated by a computer, we can later extract the parameters I was talking about a few minutes ago.
So, very interesting experiment.
Yeah, agreed. I have a quick follow-on question that people asked me already based on a previous article I wrote for the ESA website, based on your research. People are surprised that plants grow fast enough in the 20 seconds of weightlessness to actually give any results. Could you comment on that?
Yeah, I can comment on that. In fact, what we are doing, this is the first experiment that looks at the roots in 3D, in microgravity or hypergravity. And indeed, here we have sequences of hypergravity and microgravity. So what we will record is a sum of these two effects. But in parallel, we applied to ESA to obtain the opportunity to conduct some other experiments using the ground-based facility. And the ground-based facility allows to simulate the microgravity in one end, but also to produce hypergravity. So then we can actually compare our results obtained in the parabolic flight with the results obtained in clinostats or in the centrifuge. It's a couple of millimeters that we can observe. And in a 2 hours flight, it is possible to see changes. Mm-hmm. But anyway, the changes that we are interested in are happening inside the cells. So meaning
there are also processes in plants, for example, in other cells too, which where you can get responses or changes in a millisecond.
Yes.
Time frame. Mm-hmm. And the methods in the recent years have so much developed to detect something like that. Mm-hmm. Electrophysiological devices, for example, measurements, that really several scientists can see changes even in plants within some seconds.
Yes.
Also, I would like to add, I'm not a biologist, obviously, but for me, I'm a simple mind, but I like to see things simply and I like to visualize them. Mm-hmm. For me, I know that liquids react immediately to microgravity, exactly. To the onset of disappearance of gravity or the reappearance of gravity. Mm-hmm. Now, a cell, as I understand, is about 80% or more of water or liquid. Yeah. So basically, cell reacts immediately as well, sends immediately to 0G, and it reacts immediately. Mm-hmm. Now, the process of how they grow will take a little bit longer. Yeah. But let's say this impacts already the processes of growth. So this is what you can see.
This happens within 2 hours. Yeah. So we will be able to see modifications. Mm-hmm. I bet on that.
Excellent.
Maybe you mentioned also hypergravity, that you will look at the roots growing in hypergravity. Mm-hmm. Obviously, during the parabola, there's also a period of hypergravity, which is the same as 1.8 G. Mm-hmm. Maybe you could comment on that for the experiments in general. Do they use that as part of the the experiment?
Yes.
Go on.
Okay. Yes, there are several experiments, especially in the field of human physiology and biology, who also use these 1.8 G phase, which is 22 seconds long, and then follows the microgravity phase, again 23 seconds, and then again 20 seconds, about 1.8 G, and then follows 2 minutes of normal G. Several scientists look also for these hypergravity phases, and they look to all the seconds of changes. What is to be seen in the plants or in the fish or at humans also. So some, of course, don't like the 1.8 G phase, not so much, but others, they use it. So again, this is, we can offer everything with parabolic flights.
The phase of hypergravity that appears before and after the 0G, so during the pull-up phase, so if I take in the little plane, during the, what we call the pull-up phase, the acceleration upward, your weight would increase nearly double, up to 1.8 times the normal weight on Earth. But I would like to take another example also. We had, several years ago, a team which was also a joint research team between the team of Professor Cavagna from the University of Milan and Professor Patrick Willems from the University of Louvain in Belgium. They studied the walking and running processes, biophysics of walking and running at different gravity level. Not only, of course, 0G would be a bit more difficult because there each step you would propel you in the air, but using the plane, they could set up the platform force over several meters and measure a subject as well during this 1.8 G. So they could have an additional measurement point at nearly 2 G, nearly double the gravity. And then they perform also this experiment in Moon gravity and Mars gravity. So they could measure the walking and the running at these different gravity levels. Actually, they showed that running on Mars would not be as simple as you may think, but walking would be much more efficient.
Are there any experiments that that are on this flight that they're using the hypergravity phase?
No, I don't think so.
Nothing different ones.
No, I don't think so. No.
I mean, my experiment, in some respect, is using.
It's an integrated experiment.
It's using the hypergravity effect. Because actually, it was reported that in hypergravity, roots normally stop growing. So this was reported, and that in microgravity there is a kind of erratic growth. So and this we will verify this as well.
Yeah.
Okay. A relatively simple to answer question, I think, from Dhananjay Hatankar. What altitude does the aircraft fly at when it's in 0G?
It's the altitude of a mountain.
0G is actually, you can recreate 0G at any altitude. You don't need to be high or far away from Earth. You can be in 0G here at the surface of the Earth. If you jump simply in the air, you'll be for a fraction of a second in 0G. Now for the plane, we fly even at altitude lower than most of the jets, most of the normal airline flight. Airline flights, you usually fly at 10 to 11,000 meters. We fly at 60,000 meters for the horizontal flight, and then the top of the parabola is about 9,000 meters. 8.5 to 9,000 meters.
And between 6 and 9,000 meters, the actual parabola flight, the injection point, is at almost little more than 7,000 meters.
What is important is that we are in a free fall state. So no forces other than gravity acting on the vehicle must be there. All forces other than gravity must be zero. Of course, you cannot null the gravity because it's always there. It's the attraction of the Earth. It's always there, but you can null all the other force, all the aerodynamic force, the thrust of the engine, and so on. And then you're in a free fall state, and this can happen at any altitude. in the air, the atmosphere, above the atmosphere, on the surface of the Earth if you jump, and so on.
For this aircraft, in fact, these altitude levels has been chosen because it was efficient for the flight time during the parabola, but it could have been done at any altitude.
But I think it's important that in this height, the performance of the engines is still very, very efficient, so that we can get enough speed and enough flexibility in providing power, so that the aircraft can be piloted safely in that area.
In fact.
And if you go deeper, of course, you could also fly parabola, but there are more air turbulences because of clouds and weather phenomena.
And also drag.
Yes, and if you go higher, then there is less oxygen and
less density of air, but less lift, less
exactly.
And,
so that is a compromise.
And less efficiency also in commands. So
okay, interesting. I think we have time for one more question. Henning Menzel wants to know, you cannot possibly take me with you one time on a flight, can you?
The answer is yes.
We can.
The answer is yes. There are two ways. The first one, this is the one you suggest, come up with an experiment. Propose an experiment good enough to be selected, so become a researcher, become a scientist, become engineer or physicist or biologist or medical doctor or student. Propose an experiment that can be recommended, that can be accepted, then selected, then you will fly with us. Or the other way, Novespace, so the owner of the plane and the company with whom we have a contract for this public flight, they organize now since 3 years, I guess. 3 years. Public flight, so what they call the Discovery Public Flight, and there anybody can buy a ticket for a price of about 6,000 euros, slightly less, 5,000 3 years. But again, I repeat, for all the young people, the students there, please continue your research, continue study, and become a scientist, become an engineer, become a physicist, a biologist. It is a fascinating world, and it is an absolutely passion. We're all here passionate about what we do, and we do not have the feeling that we come here to work. When we fly, we enjoy our passion. Our passion is space and zero-G flight, and we started like you, being interested to it. But okay, we pushed, we continue to study, we continue to strive to try to understand why this, why that, how it comes, and so on. Then we come up with ideas, and eventually, okay, we got on board, and we could fly.
And we now spoke a lot about science, but by the way, we also have to say that experiencing weightlessness, to be totally weightless, and you can move in all directions in the airplane, in the cabin, you can float. Weightlessness is wonderful, is unique. That is beside all these science.
True.
Look at our smiles.
I'm sure it is. Okay, I think that's more or less all we have time for. Would you like to have do you have any closing comments before I thank you for joining us?
It was a pleasure to be here.
Well, I would like to thank all my colleagues, to thank Novespace again, and to thank them also and congratulate them also to having set up this new plane. As I said, I mean, this is coming in a long series of flights and campaigns and planes that we used previously within Europe, I mean, with my CNES and my DLR colleagues. And everybody is welcome to join forces, let's say, with us, with Novespace, to use this plane, which is, again, I repeat, and we all agree to this, it's a unique and absolutely wonderful, beautiful research laboratory aircraft that we provide to all scientists.
Yeah, if I have to say something, I would like to thank these agencies for providing the support and the opportunity to participate in such a fantastic things. If one would have told me that I would be part of it, I couldn't believe it, but it is possible. And I came with a bachelor student this time, so he's also passionate in astrobiology, so it is possible. Yeah, thank you very much.
Thank you to you as well.
Yeah.
Okay, great. Well, thank you for doing this.
Thank you. Goodbye.
Okay,
Bye-bye.
bye-bye.
Bye-bye. Bye-bye. Thank you.